We've talked about binomial, what that is, right? The four components of it, bins, right? Geometric is this. B, binary, still okay. Still binary. Geometric is binary, still okay. Independent, still okay. Same probability, still okay. The only difference between geometric and binomial is the n. There is no fixed trials. So they won't give you a fixed number. What will they say? They'll say until you have something happens, until your first success. Like they'll say, what is the probability on the third try you make the free throw? What's the probability on like on that last question, the question we just did from the homework, the one with the credit card? A binomial question would be the one you saw, the one you did. What's the probability that at least 25 out of the 50, right? The one we just used a credit card. An example of geometric for the credit card problem would be it wouldn't give you 50. They would say, what is the probability that the third person you see used a credit card? All right. So what is the probability that the third person is a success? So that means the first person is a failure. The second person is a failure. The third person would have to use the credit card. Okay. That's how that's the difference between binomial and geometric. Okay. Um, there's no fixed number for these. Yeah. So for geometric, if there's a fixed number, it's not going to be geometric. Okay. So yeah, so binary is still the same. Still binary. Independent is still the same. Same probability throughout. That's the same. BIS are the same as binomial. There is no fixed number though. It's go until you have your first success. Okay. The formula, it's a little different. Their formula is a little different. We're missing some parts for the formula. So here's the formula here. Here's the formula for geometric. It's very similar, but it's missing some pieces. So here is the formula right here. I'll highlight it. This is the formula right here. What is it missing from binomial? Yeah, the little parentheses, n over k. The reason it doesn't have it is because the reason we used n over k for binomial, let's see, the reason we use that formula here was this what told us how many paths down our tree diagram would involve this. Like if we did tree diagrams for all these problems, right? This tells me how many paths. Well, with geometric, there's always only going to be one path. There's always only going to be one path, and I'll show you on the first problem what I'm talking about. So they don't need that part. They don't need that part. NK for geometric is always just going to be one. There's always just going to be one path. So instead of having a 1 times, they just left it off. This formula they don't give you, but it's pretty much the same formula as the one we've been using. Where is it? Right? It's pretty much the same formula as the one we've been using. The only difference with binomial is that this is not there. That's the only difference. Okay? Okay, so let's take a look at binomial. Or sorry, geometric. Okay, so here's an example. The Australian official lottery has scratch off instant lottery tickets, just like you can go buy at any kind of convenience store or supermarket, right? Scratch off, you see if you win. Australia does the same thing. They cost $1. The probability of winning the prize is 1 in 4. Okay. Mr. Urban decides that he will buy lottery tickets until he finds a winner, and then he'll stop. So X is the number of lottery tickets he needs until he gets his first winner. Okay. Find the probability that Mr. Urban buys exactly 8 lottery tickets in order to get the first winner. This question isn't binomial because there is no fixed number, right? There is no fixed number. He's going to keep buying lottery tickets until he gets a winner. It might be 1. It might be 2. He might buy 20. He might buy 30. He might buy 100 lottery tickets. There's no stopping, right? He's not saying, I'm going to buy 20 lottery tickets. What's the probability that 8 of them will be winners? That's binomial. What he's saying, what the question is saying is he's going to keep buying tickets until he gets a winner. That's geometric, okay? The question says, what is the probability that first ticket's a loser, second ticket's a loser, third ticket's a loser, fourth ticket's a loser, fifth ticket's a loser, sixth ticket's a loser, seventh ticket's a loser. On the 8th, he wins. They're asking for that probability. That's geometric, okay? So that's how you kind of know. Fixed number, there is no fixed number. It's go until you win or go until something different happens, right? So you still have a P, you still have a K, but you don't have an N. There is no N because there's no fixed trial. There's no fixed number, okay? So now that we know it's geometric, the question is asking, what's the probability that exactly 8 times, that exactly on the 8th ticket he'll win? Well, for that to happen, what has to happen on the previous 7? He has to lose, right? He has to lose. Otherwise, the 8th ticket won't be his first winner, all right? So he lost, win. Okay, there's only one way down the path for that, right? Lose, win. There's only one path. So that's why we don't have that NK. That's why we don't have this guy right here. We don't have that, okay, for this guy. So we just go straight to probabilities. What's the probability of a winner? What's the probability of success here? 1/4, right? Which is 0.25, 1/4. Either one is okay. K minus 1. So that's success. 0.25 is success, right? How many successes is he going to have? 1 success. Okay, what's the probability of failure? 0.75. How many failures is he going to have? 7. Done. Okay. I kind of did them backwards. This right here, 1 minus is this guy here. And P is this guy here. Success is always going to be to the first power with geometric because there's only one success. Okay. So this, you can use, this you don't even need a graphic calculator. You just, any calculator does this powers. But I'll show you. I'll show you on the calculator. We do have a geometric PDF and CDF as well. So if you go to your calculator, distribution. So now, instead of binom, we're going to go geomet for geometric. Okay. PDF means x equals. CDF means x is greater than or less than. Right? So this is equals. So we're going to use PDF. We're only going to put P and K. I'm only going to put P and K. I'm not going to put N. Don't need a P and K or an N because there's no fixed number. Probability of success is 0.25. We want to know on the 8th try. So that's how it's going to be. It's going to be geomet PDF P comma K. No N for this guy because there's no fixed try. Okay. Hit enter, and there's my probability. Oops. 0.033 probability that the first 7 are losers and on the 8th is a winner is around 3%. Pretty low. Here's my question. Let's see if they ask you next. Do they ask you next? No, they don't. Let me ask you next. How many would he expect to have to play before he gets a winner?
4.
It's actually 4. Yeah, it is 4. How do you get 4?
Probability was in 1 and 4. 1 and 4 typically.
So yeah, so for expected value for geometric, it's 1 divided by p. 1 divided by p. So 1 divided by 1/4 or 0.25 is 4. So I would expect the highest chances would be that on the 4th ticket he'd finally win. Okay, that's where I expect the highest bars for geometric, the highest chances. Okay, there is no standard deviation for geometric. There's no standard deviation for geometric because there's really no variability because there's only one path to there. Okay, so expected value, I'm not sure if I have it on here, but expected value for geometric, let me write this down, or in the mean for geometric is 1 divided by p. 1 divided by p. They don't give you any geometrics goodies on the test. They give you a lot of binomial goodies. They tell you how to they give you the formula for binomial. They give you the formula for mean of binomial. They give you formula for standard deviation of binomial, but geometric, they don't give you those goodies. But luckily, the formula for geometric is almost identical to the formula for for binomial. And then the mean is 1 over p. Okay. All right, so now let's do a CDF problem. Same idea, but now we have to find the probability that 5 or more, at least 5, right? So we have to find the probability that at least 5. So it takes him at least 5 tickets before he gets a winner. So this one could be, he could win on the 5th try. He could win on the 6th try. He could win on the 7th try. When do we stop?
At the 8th try.
When do we stop?
At the 8th try.
Do we know he's going to win on the 8th try? Did it say he wins on the 8th try? No. So when do we stop? Until he gets a win, right? Do we know where that's going to be? No. That could be 1,000,000. That could be 1,000. We don't know. So what we write here is we write this. We say K. Eventually he'll get to a number where he stops. Okay. Well, here's the thing with, I don't know when he's going to get a winner. It doesn't say when he's going to get a winner. So we're not going to use PDF for this one, right? We're going to have to use CDF for this one. But again, CDF starts with 0, right? So I'm going to use Geomet. CDF. It's going to ask for P and it's going to ask for K. What's P? Okay, what is it? 0.25. And then it's going to ask for K. What number am I going to put in for K? 4, yeah, 4. Because that'll tell me from 0 to 4. I want from 5 on. So this is the part I don't want. Subtract it from a whole, and there you go. Okay. So let's go to my calculator. .25. 4. So this is going to tell me the probability that he wins on his first ticket he buys. This plus the probability he wins on his second ticket he buys, plus the probability he wins on his third ticket he buys, plus the probability he wins on his fourth ticket, all added up. That's not what I want, but I'm going to take that number and subtract it from a whole, and that'll give me the number. Okay? So 1 minus previous answer, and that's it right there. 0.316. 0.316. The probability, so that's the probability that it takes them at least 5 tickets. Okay, so let's write that, let's interpret it. The probability that it takes him at least 5 tickets to win is 0.316. I would expect him to win by his fourth, right? We said by 4 was about the number, right? So this is above it. So it's less, it's about 31%. Okay. All right. So here are the Geomet PDF, Geomet CDF. Okay, when we use our calculator. All right, that's what we use. There is no N because there's no fixed trial in this. Okay, it's only a P and a K. All right, so last example. Last example for this guy right here. Okay. 25%. I wish they would use a different probability, but oh well. Okay, suppose Joanna is a salesperson at Macy's. Recently, she has been selling a pair of jeans to roughly 25% of everyone who tries them on. So everyone who comes in and tries on the jeans, about 25% of them end up buying. Okay. This afternoon, 20 customers will be trying on jeans. What is the probability that the third customer will be the first to buy jeans? Right there. Will be the first. That's geometric. That tells you it's geometric, right? It's binary. They either buy or they don't. Independent, just because one person walks in and buys jeans, has no bearing on whether another person comes in and buys jeans. Success is always going to be 25%. But this one doesn't have a fixed number. It actually does have a fixed number, right? 20 customers. But the wording of the question, do I really care about 20 customers? No. The question itself, I don't care about the 20 customers, right? If the question was what is the probability that 3 out of the 20 would buy, then that's binomial. But this is the first one to have success. So there could be 20, there could be 50, there could be 100, there could be I don't know how many. That doesn't matter to me. In the first question, it might matter later, but in the first question, 10A, it doesn't really matter. Okay, so it's binomial, or sorry, geometric. So we want the probability of exactly 3. The probability of exactly 3.
Third person buys. Okay. Probability of success, 0.25. It's not always going to be 25%. It's just a coincidence. How many successes am I going to have? With geometric, you only have one success. Binomial, you have more than one. You'll have different. But for geometric, you only got one success. What's the probability of failure? 0.75. How many failures am I going to have? 2. Okay. Again, these numbers aren't very hard to crunch. You can use geometric PDF, but you don't really need to. You're just going to go 0.75 squared times 0.25. And you get 0.141. Okay. What is the probability that at least 5 people, that it will take at least 5 people to try on jeans? So what does at least mean? Greater than or equal to. Okay, so that's like saying, what's the probability the 5th person tries on jeans or buys them? Plus, what's the probability the 6th person? Plus, we're going to go on this one. Well, they only said 20, so we don't have to go. We have an actual number to stop at. Most of the time, they won't tell you that. Okay. We're going to use CDF. What are we going to plug in to CDF? Yeah, that's going to be our K. 4, we're going to plug in. Let me get my calculator. Yeah, it's the same as the last one. Yeah. That's just coincidence. It won't be. I think it was probably some sort of error, typo or something like that. They probably meant to change the probabilities, but they didn't. 0.25, x is 4, right? That's the probability that the first person will buy, or the second person will buy, or the third person will buy, or the fourth person will buy, right? We don't want those. We want the probability it's 5 or more. So we're going to go 1 minus that. And it will coincidentally be the same probability as the one in the previous question. 0.316. Okay. And the very last question, how many people would we expect to try on jeans? How many people would we expect to try on jeans before they buy one? Expected value. Expected value for geometric is it's 1 over the probability. 1 over the probability, which is 1 over 0.25, which is 4. So I would expect the 4th person to buy jeans. Okay. All right, that's the difference between geometric and binomial. And most of the time it's going to be binomial, but they will throw in some geometric in there just to see if you know the difference. But the only difference between geometric and binomial is trials until first success. Go until something else happens. Go until you get a winner ticket. Go until someone buys jeans, right? Go until something else happens, a success, whatever success is. Okay, that's the only difference between geometric and binomial. Okay. All right. Okay. The rest of the time I'm going to give you to work on the homework from yesterday. All right. I'll give you some time to do that.